This is a question from October-November 2021, and it's a titration question. All right. So this is the first titration question which I'm solving with you people. I'm reading it out and I'll be doing step-by-step calculations with this. And this is a compulsory question which comes in your ATP, right? So let's start. A student determines the percentage by mass of iron in a sample of impure iron. So what the examiner intends us to do is that he has given us impure iron and we need to calculate the percentage by mass of iron in this impure sample of iron. Now this is the problem, and this problem is guided step by step, and eventually we need to find out, they will by guided steps we will be able to find out the percentage by mass of iron in the impure iron. So let's do step by step and we'll get to the solution of this. Now the A part is the student measures the mass of an empty beaker. The student adds a sample of impure iron to the beaker and then measures the mass of beaker and the impure iron. So this is the mass of a beaker and this is beaker plus impure iron. So when you will subtract it, both the values from one another, we will be getting the mass of impure iron there. So the mass of impure iron on subtracting, we are getting the answer 1.78 grams, right? When we subtract it. Now, an excess of sulfuric acid is added to the beaker containing impure iron. So whatever the iron, the sulfuric acid react with an iron, whatever the mixture you have, whatever the impure iron you have, you will be adding sulfuric acid to it. So H positive ion, whenever you are adding, that means you're adding an acid. So an acid will react with only the iron part of the mixture. It will not react with the rest of the substances. So when it reacts with iron, so it is going to form iron salt. They have given you the ionic equation for that. In the form of an iron, it will be converting into iron 2 plus, and you will be getting the hydrogen gas. So this is basically your ionic equation for the reaction, where the iron only out of the mixture is reacting with the sulfuric acid, forming iron 2 and giving you hydrogen gas. Now, let's move ahead and see what is there in the question. Hydrogen gas is produced in the reaction. Give a test and the observation to identify the hydrogen gas. So hydrogen gas, we need to know the test and the identification mode. So the test is that when we bring a burning splint close to the mouth of the test tube containing or liberating hydrogen gas, observation will be what? It will extinguishing with a pop sound. So that's an observation. If this thing happens, if the flame or the burning splinter, if it extinguishes giving pop sound, then the presence of hydrogen is confirmed. Moving ahead. All right. Now, after this, what they have done next, impurities in the impurities in the impure iron do not react with or dissolve with the sulfuric acid. So impurities remain intact. Impurities, they remain in the solid form, right? Whereas the iron has converted into iron 2 aqueous solution on reacting with the sulfuric acid. Now the impurities are separated from the aqueous solution. The aqueous solution is of iron 2 salt solution, iron 2 sulfate basically. So from that you will be removing impurities and will be performing the process of filtration. So on filtering, we will be getting the impurities on the filter paper as a residue. And in the conical flask, we'll be getting the filtrate as iron 2 salt solution. Now suggest how the student makes sure that no iron 2 remains on the filter paper. So these are very small tips which the students can easily think of if they have gone to the lab to perform such small lab activities. Now how you can ensure that none of the iron 2 is basically trapped on the filter paper along with impurities. So what we will do is we will wash our impurities. If we wash our impurities, by water, or we add distilled water, what we can do is we can add distilled water to this. अगर हम इसके अंदर distilled water ऊपर से spray करेंगे और ऊपर से डालेंगे, तो उसमें क्या होगा, जितनी भी iron sulfate, iron 2 ions होंगे वो wash out होके वो नीचे आपको सोल्यूशन का पार्ट बन जाएंगे, ठीक है। तो यहाँ पर आपके पास प्योर फॉर्म इम्प्योरिटीज आ जाएंगी, और जो भी आयरन 2 के जो पार्टिकल्स जो यहाँ पर अगर रह गए थे, दे वर ट्रैप्ड अमंग द इम्प्योरिटीज, दे कैन वॉश आउट एंड दे कैन बिकम द पार्ट ऑफ द filtrate. So simple suggestion is that we will be washing the impurities. We can add the water further, ठीक है, in order to wash out the iron 2 and make them the part of the filtrate, right? Okay, going ahead. All right, so the next is just a second. Okay, after this we have the next part of the question, and it says that the filtrate is transferred into the conical flask, from the conical flask into the volumetric flask. Now remember, this is a different kind of apparatus, and the volumetric flask is only in order to make the saturated solution. Many a times they ask you what is the apparatus to make the saturated solutions in the lab. So in order to make the saturated solution, saturated solution can be of 250 cm cube, or it can be of 500 cm cube, or it can be 1 dm cube. So all these saturated solutions are made in the volumetric flask. So whatever the solution, whatever the filtrate you had in the conical flask, you're going to transfer that into the volumetric flask in order to make the saturated solution. Now suggest how the student should make sure that all the filtrate is transferred from the conical flask to the volumetric flask. So what you will be doing in this scenario, so wash the contents. How will you do it? It's the 2-mark question. So when you're transferring from a conical flask into the volumetric flask, my drawings are really bad. This is kind of a volumetric flask. Hold on. Okay, into the volumetric flask, I'll just write down into the volumetric flask. What I'll do is that I will wash the contents of the conical flask with water and then pour back and then add those washing into the volumetric flask. So what I'll do is I'll wash the content of conical flask and will add my washings, whatever the water I've added to the conical flask after thoroughly rinsing it, ठीक है, उसको swirl करने के बाद, उसको अच्छी तरह से wash करने के बाद, I'll pour it into my distillation flask, ठीक है, into the volumetric flask, sorry. Fine. Then comes the solution in the volumetric flask is made to 500 cm cube. So in the volumetric flask, right? In the volumetric flask, whatever the filtrate you have added, so volumetric flask has particular line or a mark. So if for example you have the chemicals filled up till this level, ठीक है, तो अब आप क्या करेंगे, उसके अंदर और water add करेंगे very carefully, because this is something which is required for the titration result, that आपका saturated solution बहुत ही precise और accurate बना हुआ हो. तो very cautiously, either using the burette or pipette or any other apparatus, बहुत careful आप इसके अंदर बाकी का water add करके यहाँ पर इसके stopper लगा के और उसको अच्छे से shake करेंगे, ताकि आपके पास uniformly distributed एक particular evenly concentrated solution बन जाए, which is of 500 cm cube. तो अब इसके अंदर 500 cm cube solution, 500 cm cube solution में है क्या? This is basically your iron 2 plus solution. Now the student transferred 25. अब इसके अंदर उसने 500 का बनाया, लेकिन उसने इसका क्या किया, उसमें से इसने सिर्फ 200 जो है वो ट्रांसफर किया into a clean conical flask. Now out of 500, he is going to transfer just 25 cm cube into the conical flask and making it ready for the titration result. Okay. Now name the piece of apparatus used to transfer 25. We know that we have a pipette. The pipette is to transfer any fixed accurate volume of the liquid. So you will be using pipette, and the precaution, many a time they ask you. So we will be using pipette filler as a precaution. पिपेट फिलर एज अ प्रिकॉशन, सो दैट द पिपेट में जो लिक्विड फिल होता है वो सक्शन की वजह से होता है. अगर हम मुंह से उसको सक करेंगे पिपेट से केमिकल को, तो देयर आर चांसेस दैट वी माइट suck in the chemical into our mouth. तो हम उसको पिपेट फिलर यूज करके, पिपेट फिलर इज को यूज करके उसके अंदर लिक्विड फिल करेंगे. तो ये प्रिकॉशन होती है while filling the pipette, right? अच्छा, मूविंग अहेड. we have the next part is the solution Q. There's another solution. Now, now there's a solution Q that is 0.0100 mole per dm cube and it's KMnO4, right? So they are taking the solution 2, which is Q, and the student washes out the burette with the distilled water. पहला उसने distilled water से wash किया, washes out the burette with the solution, fills the burette with the Q. तो जब भी हम ब्यूरेट को वॉश करते हैं और प्रिपेयर करते हैं फॉर द टाइट्रेशन रिजल्ट, always remember, we always, the first step is we wash it with distilled water. We wash the burette with the distilled water. हो सकता है इससे पहले जो एक्सपेरिमेंट बच्चे ने लास्ट लैब में किया हो तो उसके अंदर उसने कोई और केमिकल फिल किया, तो उसके अंदर हो सकता है उसकी ट्रेसेस हों, दे माइट बी द चांसेस कि वो मिस आउट हो गया फ्रॉम द वॉशिंग बाय द लैब स्टाफ. तो आप अपने एंड पर प्रिकॉशनरी वे में पहले उसको हमेशा ब्यूरेट को रेडी करते हैं बाय वॉशिंग इट विद द डिस्टिल्ड वाटर. और सेकेंडली, दिस ब्यूरेट which you are washing with the distilled water might have उसके अंदर traces of water रह जाएंगे. तो अगर आप इसके अंदर डायरेक्टली अपना सोल्यूशन डालेंगे तो वो सोल्यूशन जो आप उसके अंदर ऐड करने जा रहे हैं जिससे आप एक्सपेरिमेंट परफॉर्म करेंगे तो वो सोल्यूशन आपका डाइल्यूट हो जाएगा. तो अब इसके अंदर जो वाटर के ट्रेसेस हैं उनको हम कैसे रिमूव करेंगे, तो सेकेंड टाइम हम इसको वॉश करेंगे उस केमिकल से जो हम इसके अंदर फिल करने जा रहे हैं. तो क्यू से हम इसको फिल करने जा रहे हैं, क्यू हमारे पास ब्यूरेट में आएगा तो हम क्यू से उसको वॉश करेंगे ताकि क्यू के ट्रेसेस इसके अंदर रह जाए और वो आपके फर्दर सोल्यूशन को डाइल्यूट ना करें. तो हमेशा याद रखिए कि ब्यूरेट को सबसे पहले हम डिस्टिल्ड वाटर से वॉश करते हैं और उसके बाद जिस सोल्यूशन से हमें उसको फिल करना है हम उससे वॉश करके उस केमिकल को ज़ाया कर देते हैं और उसके बाद फिर हम फ्रेश वो सब्सटेंस या वो केमिकल फिल करते हैं for the accuracy sake. Now the student shows three titration. The diagram shows the part of the burette with the liquid level at the beginning and the end. ये आपकी हमेशा accuracy के लिए हम three set of titration करते हैं. ये आपका burette की stem है और हमेशा burette को हम upside down read करते हैं. Always upside down we read it. जरूरी नहीं है कि आप हमेशा burette को zero से ही स्टार्ट करें, आप किसी भी पर्टिकुलर पॉइंट पर आप उसको इनिशियलाइज कर सकते हैं. सो दीज आर द थ्री रीडिंग्स and on the basis of these three readings, this is my initial reading for the burette and this is my final reading for the burette. तो initial और final आ जाती है तो फिर आपको पता चल जाता है दोनों को subtract करके तो actually how much volume has actually neutralized or reacted with 25 cm cube of the chemical which you have in the conical flask. So let's see कि अब हम इसकी burette की reading को हम table में किस तरह से measure करते हैं. Okay. All right. तो अब हमारे पास ये स्टेम्स हैं, ठीक है, और इन स्टेम्स के बेसिस पे हमारे पास जो वैल्यूज आएंगी, अब आप देखिए मैं थोड़ा सा स्लाइड को छोटा कर रही हूँ ताकि आप both the things are together on the same page, right? So on the basis of these stems of the burette, let's enter the values. So for the first iteration, my value, because it's starting from 0 और यहाँ पर 0 से 1 के बीच में आपकी 10 मार्किंग्स हैं. तो 10 मार्किंग का मतलब है नेक्स्ट 10 मार्किंग्स हैं, ठीक है. तो इसका मतलब जो नेक्स्ट वैल्यू है वो 0.1 का होगा, उसके बाद 0.2. हमेशा याद रखिए कि 0, if you just writing down burette की हमेशा reading 1 dp 1 decimal place तक होनी चाहिए. So if you just writing down the initial burette reading for experiment 1 as 0, so the examiner will deduct 1 complete mark. So your burette reading should be up till 1 dp 1 decimal place. So we'll be writing down that the initial reading was basically 0.0, right? Now the final reading is how much? We will be always reading upside down. So it's going to be 23 point something, 23 point. When you measure it, it's going to be 23.8. Now, let's fill in for the second and the third titration as well. Now, this is basically 10.4 is my initial, and my final is 34 point. It's going to be 34.6. And for the third titration, I'll be having the initial as 12.3, and the final is basically 36.1, right? Okay, so it's 36.1. What I'll do next is that on subtracting these two values, I'll know exactly the volume of Q, how much will be used in order to neutralize 25 cm cube of the chemical I have in the conical flask. When I'll subtract these two, I'll have the values, that's 23.8. I'll have the value here, that's 24.2. I'll have the value here, 23.8. Now the next step, they're asking you to mark the best titration. So best titrations are the one which are close together. So my best titrations are basically these are extremely close, or they are absolutely same. So these are my best titration results. So I'll be putting a tick under the best titration result. And what is the next step? They ask us to you have to put the tick under this, and then they ask us to take an average of the tick ones, the best titration. So when you'll be taking an average 23.8 added to 23.8, because both these values are same, we will be getting an average of 23.8 only. So what we have to do is we have to exclude the value which is not a बेस्ट टाइट्रेशन रिजल्ट. तो जो आपकी बेस्ट टाइट्रेशन रिजल्ट्स हैं उनको, जिनको हमने टिक किया उनका हम एवरेज निकालेंगे और आपका 23.8 एवरेज निकालने का आंसर है. आई होप आई एम क्लियर. ओके, तो हमारे पास जो एवरेज आया था, एवरेज वॉल्यूम वी गॉट दैट वाज 23.8 cm3, राइट. नाउ अब इन्होंने यहाँ पे Q की बात करें, Q पोटेशियम परमैंगनेट which is basically is there in the burette. Now 23.8 is actually neutralizing 25 cm³ of iron 2, जिसका मैंने saturated solution बनाया था, जिसको मैं conical flask में using the pipette मैंने उसको निकाला था. ठीक है, तो 25 cm³ of iron 2 is being neutralized by 23.8 cm³ of potassium permanganate of this particular concentration. Now we need to find out the moles of potassium. Now this I have already explained in my video on moles in solution, that whenever we need to find out the moles of a solution, then the formula we'll be applying is that moles equal to concentration over 1000 multiplied by the volume. So we do have the concentration, we do have the volume. So we will just simply write down, or always remember that we should be showing our working here, because in case the answer goes wrong, so at least the examiner will give you the marks after looking at your working. So what will be, we'll be finding out the number of moles where we'll write down the concentration, that 0.0100 divided by 1000. Why with 1000? Because here we have the unit dm³ and here we have cm³. In order to bring them back into the same unit form, will be dividing this by 1000, right, and multiplied by 23.8. On simplifying these values, I'll be getting the answer that is basically I'll be getting 0.000238, right. So it's better to write down in the decimal form rather than the standard form. And one more thing, very importantly, over here you can round up the value while writing the answer here, but whatever the calculator's value you have, you are going to proceed with your calculator values. जो भी आपकी कैलकुलेटर की जो वैल्यूज हैं उसको आप राउंड ऑफ नहीं करेंगे, उन्हीं वैल्यूज से लेकर आप प्रोसीड करेंगे, क्योंकि आपके लेटर पार्ट्स में अगर आप यहाँ पर राउंड ऑफ करते हैं और उन्हीं राउंडेड ऑफ वैल्यूज को लेके आगे के स्टेप परफॉर्म करते हैं, तो आपका और एग्जामिनर का जो आंसर है, फाइनल आंसर या लास्ट आंसर, में बहुत ज्यादा वेरिएशंस आ जाएंगी, और उन वेरिएशंस की वजह से यू विल नॉट स्कोर द लास्ट मार्क व्हिच इज द फाइनल आंसर. ठीक है, तो व्हाट वी डू इज, नाउ अकॉर्डिंग टू द रूल, हम यहाँ पर अप टिल 2 to 3 सिग्निफिकेंट फिगर्स में आंसर लिखते हैं, लेकिन जो कैलकुलेटर की जो वैल्यूज है उनसे हम प्रोसीड करते हैं आगे की कैलकुलेशंस. नाउ आइदर इन द नेक्स्ट स्टेप वी नो दैट हाउ मेनी मोल्स ऑफ KMnO4 आर कमिंग फ्रॉम 23.8 cm³ of KMnO4 which are neutralizing 25 cm³ of my iron 2 solution. Now I don't know, अब मुझे ये निकालना है कि 25 cm³ के अंदर कितने मोल्स होंगे, तो उसके लिए अपने एग्जामिनर हमें इक्वेशन देगा या फिर वो आपको मोलर रेशियो देगा. यहाँ पर वो कह रहा है कि 1 mole of KMnO4 is reacting with 5 moles of iron 2. अब ये KMnO4 के मोल्स हैं, ठीक है, तो KMnO4 और iron 2 का जो रेशियो है वो 1:5 का है. अब आपके पास यहाँ पर KMnO4 के मोल्स हैं, तो KMnO4 के मोल्स कितने हैं, 0.00238. तो अब आप iron 2 के निकालने के लिए what you'll do is the same number of moles you will be multiplying how many times, 5 times, in order to get the iron 2 moles in 25 cm³, right. So the answer will be the answer is going to be 0.00119. These many moles are of iron 2 in 25 cm³, right? Now, if in 25 cm cube we have this, then the next part is demanding that how many moles will be there in 500 cm cube, which we have initially formed. So if 25 cm cube has got 0.00119 moles, then 500 cm cube will have X. So we will be having 0.00119 divided by 25 multiplied by 500. So our answer will be, the answer is going to be 0.0238. So these many moles will be there in 500 cm cube of iron 2 which we have formed. These iron 2 ions are actually formed from pure iron which was there in the mixture, and this iron 2 was made up till 500 cm cube. So 500 cm cube of iron 2 which is actually formed from iron, the pure iron, has got how many moles? 0.0238 moles. Moving ahead, let's see what else they have given us ahead. Okay, now we know the number of moles. Now they're asking us the mass. Now we have another formula here where we, from the moles, we can calculate the mass. That is moles equals to mass divided by AR or MR. AR we take if we have an element, MR if we take if we have a molecule, have a compound. Remember one thing, that in the ATP paper we don't get the periodic table. So whatever the values of AR or whatever the values, they will be given to you as a part of the question. That is the reason they have given us the iron as 56. Now moles we are taking from the step ahead. AR we know it's basically 56, right? It's 56. Now when we will be multiplying these moles with the AR, we'll get the mass, right? So the mass I'm getting here is basically 1.33 grams, right? So this is 1.33 grams is the mass, right? Now I have to calculate the percentage by mass of iron in impure. Now this is the mass which I have of iron, right? क्योंकि ये iron जो है ये iron 2 फॉर्म करे और iron 2 के moles से हमने उसका मास निकाल लिया कि 1.33 है। और इनिशियली इन द फर्स्ट स्टेप जहां पर हमने बीकर से बीकर प्लस इम्प्योर substance का जब mass निकाला था, that was 1.76. So we have the pure mass of iron, that's 1.33 divided by the impure mixture of iron, that was 1.76. And because we have to find out the percentage by mass, so we'll multiply this by 100. So on doing this, we will be getting the answer. Whatever the percentage, you compute it, and that is going to be your percentage over here. I hope I'm clear. You will be getting around 74.9%. So this is 16 mark question, and it's a compulsory question in your P4 paper. Okay, so we have another titration question here, and it's from the year May-June 21, and variant is 4.1. So let's read what is the demand of the question, and then we'll be going step by step, because ATP titration questions are all guided, right? So the question says that a student determined the concentration of dilute sulfuric acid. So this is the problem. This is the question. Sulfuric acid की इनको concentration determine करनी है when they titrate it with aqueous sodium hydroxide. So this is what they're supposed to do, and this how they're going to do it, they will be guiding us step by step. Now they're saying that a student transferred 10 cm cube of 0.10 mole per dm cube NaOH into the flask. So in the flask, I have an alkali. In the flask, I have an alkali, and this alkali is basically the 10 cm cube of an alkali. Now I add a few drops of methyl orange into the flask. Now methyl orange is an indicator. Methyl, you need to know the color changes of the indicator. So methyl orange is indicator. In acid, it will be giving you red color, and in alkali, they will be giving you yellow color. So just at neutralization, which is the midpoint, they will be showing you the orange color. So in NaOH, when you are going to add into alkali, so basically the whole solution will turn yellow because they give you the yellow color in an alkali, right? Now fills the burette with sulfuric acid. So in the burette, we have sulfuric acid here, whose concentration we need to find out. Add sulfuric acid to the flask until the indicator color changes. So initially I have a yellow color. So the color change has to be either orange, or you can mention as red. So maybe they are adding excess of drops, which is going to turn it to red, or if exactly accuracy is maintained, so we might get the orange color as well. Now, on the basis of these stems of the burette, we can record the first titration, second titration, and third titration values in the column below, in the observation table below. So let's see what the titration stems read, and we can fill in this particular table, because on the basis of the observation table, we have to calculate the average volume of sulfuric acid, which will be neutralizing the 10 cm cube of alkali, which I've taken in the conical flask. Now, as I told you before, we will be reading these burettes upside down, and we will be taking 0 as 0.0. That's very important. So let's write down the final and the initial readings for the first titration. So the initial reading is definitely 0.0. Don't forget to write down the up till 1 dp. If you write down just 0, you will not get 1 mark, because 1 mark is for each table 1 for the first titration, second titration, and third titration, and the 4th mark is for the average. So if you will not write down 0 along with the dp, 1 decimal place at 0.0, you will not get the mark for the first column, right? So unnecessarily, which is easy to gain, so why to lose your marks by making simple small blunders? All right, so this is 0.0 is initial, and the final, when you read it, it's 24.2. So I'll write down 24.2. Now the second titration, again upside down, the initial is going to be 24.2, and you when I'll perform the second experiment, I'm from 24.2 I'll start, and the color change will be seen to me when I'll add 47 points. How much is it? 47.8 cm cube, right? The third titration shows that the initial I have 1 point, I'm reading upside down, so this is showing 1.3, and the final is going to be 24. On reading it upside down, it's going to be 24.7. So from this observation, from these stems of the burette, I'm able to note down the readings in my observation table. Now I have to calculate the actual volume. What I'll do, these two values I'll subtract in order to find out the actual volume of acid, which is neutralizing the 10 cm cube of alkali I have. When I'll subtract them, I'll be getting 24.2 here, I'll be getting 23.6 here, and I'll be getting 23.4 here, right? The next line states that you have to put a tick for the best titration result. That means which are the closest one. So according to this, 24.2 is quite out. So the best titration results are 23.6 and 23.4, which are close. Now in the next part, what I'll be doing, I'll be taking the average of 23.6 and 23.4, and the average will be the in-between value, that is going to be 23.5. So basically 10 cm cube of whatever the concentration of NaOH they have mentioned above will be neutralized by 23.5 cm cube of sulfuric acid. Is that clear? So this is what we have got as an average volume of sulfuric acid. Now moving ahead, let's see what else do we have further. Now when we move ahead, calculate the number of moles of NaOH in 10 cm cube of 0 point. Now remember, again, this is moles in solution. They have given you the volume. How do we know? Because the unit is cm cube, and this is the concentration, because we have mole per dm cube as a unit. So in order to find out the moles in solution, the formula remains the same. That's if you want to calculate the moles, we will be multiplying volume multiplied by concentration divided by 1000. So volume is basically 10 multiplied by 0.100 divided by 1000. I'll have the number of moles of NaOH which are present in 10 cm cube of NaOH, right? So I'll be getting the answer, that is 0.001. So these many moles are present in 10 cm cube of NaOH. Now after that, because we have to find out the concentration of sulfuric acid, so if they either, I told you in the previous question, they have given us a ratio, but in this question, instead of ratio, they have given an equation for us to evaluate what is basically the ratio. So it's a balanced equation. So from this, we can see that 2 moles of NaOH is reacting with 1 mole of sulfuric acid. So the ratio is 2 is to 1, sorry, 2 is to 1, right? The ratio is basically 2 is to 1. Now, because we know the ratio of 2 is to 1, so whatever the number of moles of NaOH we have, so sulfuric acid will be half the number of moles we have for NaOH. So if it is the ratio of 2 is to 1, so sulfuric acid moles will be 0.001, then sulfuric acid moles will be the half of which were present in NaOH. So that makes around, that is basically 0.0005 moles will be there in sulfuric acid, which are reacting with 10 cm cube of NaOH of this particular concentration. Now, when we know the number of moles of the reacting sulfuric acid, right, we know the volume also, we can easily calculate the concentrations, right? We will be using the same formula as above. We know the moles, right? We know the moles, we know this, these are the number of moles. So this we already know. Volume also we know, the average volume in the on the previous page we calculated. We can easily find out the concentration now. So let's write down the value here. So we know the moles, at 0.0005 will be dividing it by 23.5, and on multiplying it by 1000, I'll have the concentration. So the concentration is basically 0.02127. That's a concentration of my sulfuric acid, which I'm supposed to find out, and I'm able to find out through the guided steps. Okay, so this is a 7 marks, simple, very small question, and that's all for today.